Hey class, Mr. Modi here with another financial math example, this time dealing with the comparison between two different interest scenarios. So we have an unexpected medical bill and we owe $3,200. We can pay $450 now, but the rest is being put on the card. The American Express card offers a monthly compounding with a 33.4% rate, while Discover uses a daily compounding with a 32.9% rate. In order to pay off the balance in 18 months, which is the better card to use? So a couple keywords to recognize here: monthly compounding. Those also appear in annuity problems, this phrase, but keep in mind that annuities deal with regular deposits or regular withdrawals of a fixed amount for a certain period of time, whereas here it's simply a one-time expenditure. We're paying a certain amount once, and then of course we're paying it back to the credit card company with interest. So this is not going to be an annuity problem, it's going to be a compound interest problem. The Discover card, you'll notice, is much the same. We're using a compound interest, this time with a somewhat unusual period. This time it says daily compounding, but the same formula, just a slightly different input. So let's take a look at the American Express card first. As mentioned, monthly compounding with a one-time expenditure leads us to the compound interest formula. Just to reiterate what these variables mean, P is the amount you borrow, R is the annual interest rate, N is the number of compoundings in a year. So in this case, if it's monthly compounding, N will be the number of months in a year. And T is time in years. So for annuities, your N value is the number of deposits or withdrawals, but for compound interest, for one-time expenditures, N represents something else, and T always has to be in terms of years. So we can't really use this 18 number directly if we're going to use this formula. But we're going to use the 18 indirectly. So let's go ahead and find what these values are for this particular credit card. The amount we're borrowing is not the entire 3,200, right? We can pay some of it now, and then the rest has to be charged. So the difference is what we have to put on our credit card. So we're borrowing from the credit card $2,750, and we got to pay that back with interest, right? So that's our P value. Our rate is the interest rate for the American Express card simply as a decimal. Pretty straightforward there. N is the number of compoundings a year, which in this case is 12 months in a year. And T is the time in years, which is not 18. If you use 18, you'll get a different incorrect answer. 18 is the number of months, and since there are once again 12 months in a year, we get 1.5 years as our T value. So now we have everything we need. We have P, R, N, and T to find A, the amount we actually pay for this borrowing. So plugging in those values there, P here, R over N, raised to the N times T. I found the inside number there to be this in the calculator. You can double check me if you're not sure, or if you want to practice exactly going through this procedure. And then I went ahead and simplified the exponent. I raised this to the 18th power, which gave me that, times 2750 would give me an actual price paid back over the course of a year and a half of $4,507. So borrowing $2,700 ends up paying or costing me $4,500, which is a lot more money, right? So credit cards aren't really a good option for these kind of expenditures. Of course, sometimes emergencies happen, but this is a long period of time to pay it back, 18 months. So let's compare that to the Discover card, slightly different. The Discover card uses a daily compounding formula with a different rate. So some of these things will change, some of them will remain the same. We're still borrowing $2,750, that has not changed. Our rate is slightly different, 0.329. Our N, the number of compoundings a year, if it's daily, is the number of days in a year, 365. And once again, our time in years, still 18 months, so still 1.5 years. So this time, since the calculation is a little bit tricky, I've left out the actual steps, and we'll do that part together here with the calculator. But putting in the numbers pretty straightforward. You get exactly like the last American Express card, you get what you see here. However, when you type this in the calculator, you get some weird numbers, so let me walk through that with you so we have a better sense of what's happening. Clear out some of this. All right. So since we're dividing the interest rate, 0.329, into 365 different ways, we're dividing it by n here. then we have 0.329 divided by 365. And we get a very small result. Remember, this is scientific notation. It's telling us to move the decimal digit 4 places to the left. So you have 0.000901369, etc. So what we're doing to that's this number right here. Add that with 1, and we have something a little easier to understand. Okay, that's being raised to the following power. 365 is n, the number of compoundings in a year. For how long? For 1.5 years, or 18 months. But we need to use time in years for compound interest. So all this business over here, in parentheses raised to an exponent, gives us 1.6376. Multiply that times the p-value, which is 2750, and you get a actual payment amount of $4,503.61. So looking back at the American Express had us pay $45.07, whereas the Discover has us pay $45.03. Optimally, we'd like to pay as little as possible in interest, so this is indeed the better choice based on our calculations here. Alrighty, hope this helps.